Good morning. Once again, this is Mr. Herman. This video will be talking about solving exponential equations with different bases using a second method. Okay, so the first two videos that you've hopefully watched talk about solving exponential equations that have two bases and that have two exponents. Okay, whether the bases are the same or whether the bases are different. This set is going to look a little bit different in that one of our sides of the equation will not have an exponent. Okay, so we will have something that looks like this. So 4 raised to the 2x plus 1 equals 5. So 4 and 5, we can't write those so that they're the same. Okay, if we were to try, we've got 2 raised to the first equals 2, 2 raised to the second equals 4, and then we've got 5 sitting over here. Okay, there's no way that we can multiply 4 by itself, or 4 times 2, or 2 times 2, to get some version of 5. So what we have to do then is we have to use our logarithms. All right, so we've talked about logarithms so far as the inverse of exponential functions, and so that's how we're going to use them here. However, in this case, we're actually not really going to use our logarithm as much as we're going to just rewrite what we have given to us. Okay, so this exponential equation, we can solve it by taking the logarithm, but all that's going to look like is rewriting this equation. Okay, so a week or two ago we talked about rewriting exponential equations into logarithmic notation. And that's something that I think that we thought was rather simple, because all we were doing is rearranging parts into an order that sort of made sense to us once we looked at a pattern. So if we were to rewrite this into logarithmic notation, we're going to have that log out here, base of 4 of 5 equals 2x plus 1. Okay? Now the one tricky thing is if we want to evaluate log base 4 of 5. Our calculator might be able to give us that. Okay? I'll put a list of where you're going to go for your calculator notation on here. You'll go to Math A, which should say log base. Okay, you'll type in something that looks just like this. If you've got a problem with that, if you don't get that on your calculator, just talk to Mr. Herman and he can help you with that. So once we get that in our calculator, I'll go ahead and put that in my calculator and get that as a decimal. Okay, that decimal is going to be 1.161. We'll just round to 3 decimal places. And then we'll say equals 2x plus 1. And then we're just solving this like a classic two-step. Okay, that's all we're doing these days, just solving two-step equations. Okay, so we'll subtract 1 from both sides. So we get 0.161 equals 2x. Divide both sides by 2. X equals 0.0805. Okay, if you had 0.080, that would be fine. 0.081 would be fine as well, or you could have 0.0805. Okay, it'd just be different based on how you round it. Now, what we can do is we can go ahead and check this. I'll just use the 0.0805. And let's go ahead and let's say 4 times 2, or 4 raised to the 2 times 0.0805 plus 1 equals 5. Okay, so I'll go ahead and put that on my calculator, see if that checks out. We've got 4 raised to the 2 times 0.0805 plus 1, and that equals, so my calculator says, you can read that, 5.0002491. Okay, so it's not exactly 5, but the reason for that is because back here we decided to round this number. We rounded this number. Okay, so with rounding both of those numbers, it's not going to be exact. Okay, but we got 5.000 with a little bit of stuff after that. That's close enough. Okay, so we essentially have 5 equals 5. And so our answer would be correct that x equals 0.0805. Okay, we'll go ahead and do one more example, and then we'll put some steps to that solution method. All right, So let's take a look at 7 raised to the 3x plus 1 equals 9. Now once again, we've got a problem here. We can't say, well, 7, what can we multiply? Can we multiply 7 times 7 to get 9 or 3 times something? That's just not going to work for us. Okay? So what we can do is we can instead rewrite this into log notation. Okay, so log notation is going to tell us we have log base 7 of 9, okay, just like we looked at the past couple weeks, equals 3x plus 1. Okay, so we'll go ahead and put log base 7 of 9 into our calculator. Go to math A, log base, 7, and then 9 will give us approximately 1.129. Okay, and that's equivalent to 3x plus 1. I just solved that classic two-step. Okay, if you've got these concepts down, the new ones that we're doing, we're just going to be using some old skills that y'all have been working on for years, solving those equations. Okay, so then we'll go ahead and divide both sides by 3, divide both sides by 3, and x will equal, let's see, minus 1. Divided by 3, x will be approximately 0.0431. Okay, so now once again, that's not going to be exact. Okay, a little bit of rounding while we were doing this, but we'll go ahead and check just to see it should be pretty close. Maybe not exact, but it should be pretty close to what we're looking for. So we got 7 raised to the 3 times 0.0431 plus 1 equals 9. Alright, so I'm going to type that into my calculator. 7 raised to the 3 times 0.0431 plus 1 equals, and I got 9.002626169. And while it's not exactly 9, it's pretty darn close. Okay, so that's enough to say that yes, those are equivalent, and that we did solve this one correctly. Okay, so our steps. Alright. So 1, move equation into log notation. Okay? I'll put it in the light for you. We're going to move our equation into log notation. Okay? And then once we've got that, okay, so we did that here, we want to evaluate the logarithm. Evaluate the logarithm and solve for the variable. Okay, so this last method that we've looked at, solving exponential equations, it's using our logarithms, okay, but it's actually not that difficult. Okay, we're just putting it into log notation, which we thought was rather simple, and then just solving an equation like that. Okay. On the next part of GlenSpace, you have a short assignment solving exponential equations using this method. We'll talk about these on Friday, so if you have any questions, we'll answer them then. Okay. Thanks for watching.